Types of chemical reactions. Chemical reactions can be classified in following types. Combination reaction. Decomposition reaction. It has its three parts. Thermal decomposition. Electrolytic decomposition. And photolysis or photodecomposition reaction. Displacement reaction. Double displacement reaction. Oxidation and reduction reactions. In this video we will discuss only combination and decomposition reaction. We will discuss the remaining reactions in the next video. Reactions in which two or more reactants combine to form one product are called combination reactions. Combination reaction is also known as a synthesis reaction. A general decomposition reaction can be represented as follows. A plus B converted into AB. Let's try an activity for better understanding. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Check temperature of the solution. Do you notice any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime or calcium hydroxide and releasing a large amount of heat. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Here are some more examples of combination reactions. Burning of coal. Formation of water from hydrogen and oxygen. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Examples of exothermic chemical reactions are burning of natural gas and respiration, in which glucose combines with oxygen in the cells of our body and provides energy. Decomposition reaction. Reactions in which one compound decomposes in two or more compounds or elements are known as decomposition reaction. A decomposition reaction is just the opposite of combination reaction. A general decomposition reaction can be represented as follows. AB converted into A plus B. When calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. Thermal decomposition. The decomposition of a substance on heating is known as thermal decomposition. Let's try an activity. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp. Observe the color of the crystals after heating. The green color of the ferrous sulfate crystals has changed. In this reaction a single reactant breaks down to give simpler products. Electrolytic decomposition. Reactions in which compounds decompose into simpler compounds because of passing of electricity, are known as electrolytic decomposition. This is also known as electrolysis. Let's try an activity for better understanding. Take a plastic mug and drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by bringing a burning candle close to the mouth of the test tubes. This step must be performed carefully. First we will test the test tube which has more gas. It contains hydrogen gas. Now we will test the second test tube. In this, the flame of the candle burned more. That means, it contains oxygen gas. When electricity is passed in water, it decomposes into hydrogen and oxygen. And photolysis or photodecomposition reaction. Reactions in which a compound decomposes because of sunlight are known as photolysis or photodecomposition reaction. Take about 2 gram silver chloride in a china dish. Place this china dish in sunlight for some time. Observe the color of the silver chloride after some time. You will see that white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Thanks for watching.